Welcome, my name is Z. I'm your host for the Framework Developer Bootcamp. This show is for people who want to become web or mobile developers. Really, anyone who wants to learn programming will learn about new technologies and coding techniques each show. My goal for this show is to give you a taste of the kind of work developers do and the tools we use for every project. Today, we'll take a look at the Chrome Developer Console, an essential tool for web developers to troubleshoot their web pages. With the Developer Console, you can dissect your website to troubleshoot issues such as elements not adhering to CSS rules, slow performance of web pages, and JavaScript errors. The Chrome Developer Console gives the web developers the ability to quickly pinpoint the cause of strange behaviors on their web page, making it an indispensable tool for any web developer. During each episode of Framework, I'll be inviting you to follow along with me. As you're watching, don't be afraid to pause the video or watch it more than once so you can enter the code or type in the commands right along with me. Thanks for watching Framework. Let's get started. Today we're going to take a look at the Chrome Developer tool. You can open the tool by going to View, Developer, and Developer Tools. Alternatively, you could press Option Command I or Control Shift I if you're on a Windows machine. So we have a bunch of tabs at the top. For today, we'll only be looking at the Elements tab, the Sources tab, and the Network tab. Let's start with the Elements tab. We'll first go to our home page, learn2program.tv, and take a look. The top is the HTML document for the current page. Don't allow. This is where we can find all the elements. From here, we can actually highlight the elements on the page with HTML. If I hover over the body tag, which is what I'm doing right now, you can see that the entire page is highlighted in blue. If I hover over some other tags, such as the script tag, nothing is highlighted. That's because the script tag, among others, are not rendered on the page. That's because they're simply JavaScript that gets executed. There's no UI elements associated with them. If we scroll far down enough, we'll see a dev tag with the class viewSchool. If we highlight that, we can see that the entire page gets highlighted again. If we hover over the tags below those, it seems like nothing's highlighted again. That seems to suggest that all of the page's content is within that div tag. Let's expand it and take a look. We can see the div tag with the homepage-hero class, which seems to be the big banner at the top. And we see a few div tags with the container class. Which seem to contain the student testimonials. We can find the elements by going through the HTML tree, but depending on how complicated the website is, it might be time-consuming to look for specific elements here in the HTML. There's an alternative way to find an element with the UI selector here. If you click on the selector and then move over to the UI, you can see that your mouse is now highlighting all the elements. So for example, if we want to take a look at the yellow button that says join for free, let's hover over it. If we click on it, notice on the right, this anchor tag here with the class primary, button, HG, and text center is highlighted. So we use this tool over here to find this UI element in HTML. So far we have seen how to examine the HTML code of a web page, as well as finding the corresponding HTML elements from the web page by using the selector tool. Next, we're moving down the developer tool to take a look at the CSS rules to see how what we just learned may be useful in combination with the rules. So in the Styles tab here, we have all the CSS rules that the developers specified, either inline or in a CSS file, on this particular element. There are also some default browser rules that we can see at the bottom. Notice that some of these rules are crossed off. That's because they're overwritten. For example, if we take a look at this border radius rule here, it's marked 32 pixels with exclamation mark important. And just as a side note, in case you're not familiar with CSS, CSS rules are weighted based on specificity. A more specific rule will override a less specific rule. And if both rules are of equal specificity, the latter rule will override the former. For example, if you put down font size 12 pixels for H1 tag, and then later in the CSS you put down font size 14 for the same tag, the H1 tag will take the value of 14 because it comes later. The order of specificity in CSS is as follows. The tag selectors are the least specific, meaning the H1 tags, the div tags, the paragraph tags, followed by the class selectors, and then followed by the ID selectors. That means if there's a conflict of value, values assigned using an ID selector will override values assigned using a class selector. Then we have the exclamation mark important, which will override all of the selectors we just mentioned. Here, we have a border radius of 20 pixels, which is overwritten by the top rule that has an exclamation mark important after it. We could toggle these rules off by unchecking the box in front of them to see what happens. Notice that the elements on the page is changing as well. As we toggle these rules on and off. This brings us to arguably one of the most important features of the Chrome developer tool for front-end developers. From here, we can experiment with CSS to see how they will look on the page. We can actually edit the rules or even add them. For example, if I want to change this 32 pixel for border radius to, let's say, 8. And notice how the button the border radius just changed here. If I change it to 50, or maybe even 500, notice how the border radius is changing as I type. So we can edit the value here to try to experiment with all the different values. So let's put an 8 here for now. And aside from editing all of these values, as well as the attributes themselves, we could also add new values. For example, at the top, I could say, if I want to change the font color to black, we could type color, black. And notice that the font just changed. The font color just changed. Know that if you refresh this page, let's hit the refresh button, everything goes back to the original. That's because you're not editing the web page that's hosted by learntoprogram.tv. You're only editing a copy of it in the browser on a local computer. That's a good thing, because if you think about it, it would be a serious security flaw if you were able to modify any websites from your browser. To the right of the CSS rules, we can see boxes of different colors within each other. This shows us the margin, the border, the padding, as well as the dimension of the element. For example, if you're curious about the font size of this element, below that, we have a list of all of the rendered CSS rules with its various values applied to the current element. For example, if you're curious about the font size of this element, or if you're having a hard time finding that information on the left-hand side, you can simply type the attribute in the filter. And you can get the value right away instead of having to look for it or guess what it could be right now. Below the CSS rule section, we have a console tab. This is where all the JavaScript errors are displayed. This is where you'll find errors like failure to load certain resources, JavaScript exceptions, as well as any custom logging that you may be doing with the console.log statement in JavaScript. This is also a handy JavaScript terminal for you to test out some JavaScript code if you're unsure of something. For example, if you're not sure what the parseIn function would do with a string input, you could test it out here. So next, we'll take a brief look at the Sources tab. This tab lists all the files that are used by the browser to put together the current web page. You may be wondering why there's so many files and folders here for this one page. That's because under the hood, the page uses many tools, such as analytics, static content storage, front-end frameworks to make it work. We're not going to go into details on what all of these files do, but one handy feature I will point out here is the ability to put breakpoints in JavaScript. If you're not familiar with breakpoints, it's a handy feature that allows developers to pause a program in execution, so the developer can examine the various parameters when the program hits that line to facilitate troubleshooting. For example, let's take a look at this analytics.js file. So this is a JavaScript file that's used by the page. We could put a breakpoint somewhere. Let's put a breakpoint on line 44. And then since it's not getting executed, we could try to trigger it by refreshing the page. So I'm going to hit refresh. Notice that right now, on top of the page, it says paused in debugger. And in the analytics.js file, this line is highlighted. So what's happening right now is that when we refresh the page, this entire JavaScript file is getting executed, and the program is currently paused on this line. And furthermore, we also get a bunch of values that are assigned to the previous variables. So here, for example, an undefined is assigned to the name, which may or may not cause any problems. And then a 2 is assigned to mod, and then a bunch of exports assigned to m. And then the ID has a value of 1. So this really helps a JavaScript developer to troubleshoot things. If something's not working, you can see what all the values that are assigned to the variables. And lastly, we can remove this breakpoint by just clicking on it. And then we could click on this blue triangle here that says resume script execution. The last thing we're going to take a look at is the network tab. This tab shows us all the requests that are made in order to render this page, as well as various information about the requests, such as the response size, the response time, the HTTP status code, etc. Some of these responses are images, some are HTML files. For example, we could figure out what type of response it is by looking at the type here. So here is a document, it's an HTML document. And here we have some JavaScript files, style sheets, JPEG and PNGs, and etc. At the bottom, you can see how many requests were made to fetch this page, to fetch and render this page. as well as the total size of the response, and the time it took to load. This is useful if you want to get a sense of the performance of the web page. You can identify which files, most likely images, are too big, so that you can find ways to compress them and make them load faster. In this session, we will know some essential tools from the Chrome Developer Console that every web developer should know in order to build robust web applications. You learn how to inspect HTML elements of a web page, troubleshoot CSS conflicts, and testing JavaScript in the JavaScript console. Furthermore, you now have an insight into how web developers figure out what's causing problems during the development process. But why stop here? If you enjoy this show, why not give the Framework Professional Developer Program a shot? We help you become a professional developer in as little as 20 weeks. Our program is online, but everyone in the program has their own instructor. So your questions are always answered. You can try the program for free. Just sign up at learntoprogram.tv/p/try-framework. See you next time.